So we want to prove that A multiplied by B, all inverted, is equal to B inverse multiplied by A inverse. Of course, we're only talking about square matrices A and B here for the inverse to be well defined, and we're going to prove this in the 2 by 2 case. So as our first step, we just write A in component form, okay, so A11, A21, A12 and A22 are just arbitrary numbers, and next out we're going to write the inverse of these matrices. So we multiply the matrices A and B together, and we do this by going along the columns of A, the rows of A, and down the columns of B. So for example, this first component, the 1, 1 component, we go across the first row and down the first column. So we get A11 times B11 plus A21 times B12. And we keep doing that for the other components too. Okay, so to find the inverse of A multiplied by B, we first have to define the determinant, as this is involved in the formula. And don't worry, this absolute mess does simplify down. We've multiplied the top left component and the bottom right component, and then subtracted the product of the bottom left component and the top right component. And then we've expanded out, and we're going to simplify it now. So when we cancel out a couple of the terms, and then when I've rewritten the determinant, I have brought the A's together and the B's together so that we can see this factorization a little bit more easily. And this is actually the determinant of A, and this is the determinant of the matrix B, which is good, because if we're wanting to prove that A times B inverse is equal to the inverse of B multiplied by the inverse of A, we know that the determinant should be this combination, because these terms are going to be involved in the inverses of B and A respectively. Okay, so that's a good start, and we'll carry on with the proof now. Okay, so to finish finding AB inverse, well, we know what the determinant is, so we can just write that in. And then we swap these two over. Obviously they've already been swapped, so don't swap them again. And then we change the sign of the other two elements. And you can confirm this by multiplying out these two matrices here, that that is equivalent to this. And this is, of course, B inverse, A inverse. So this is a nice example of a direct proof. I have some other videos on proofs involving the transpose of matrices that work really in a very similar manner. And this is a way you can solve a lot of matrix problems, obviously when the dimensions of the matrix are specified, by just working through in this manner. So I hope you enjoyed this video. It's a simple but slightly long-winded proof. If you have any questions, let me know down in the comment section below, and I hope to see you in the next video.